Okay, so disadvantages, consistent results. Let's say there are a lot of artists that say that they love electric kilns, but they're too consistent. Nothing exciting ever happens. And that depends on your perspective and how important reproducibility versus serendipity is. Okay. Let's see here. Oxidation. You can only do oxidation firings, basically, which means that when you're firing an electric kiln, you've got an excess of air in the kiln. So essentially, all your firings are oxidation firings. You can do localized reduction in saggers if you want to put a pot inside of another ceramic container and put reduction in there. But you can't do a whole kiln load unless you want to do a whole kiln load of saggers. This is one case where I think like gas kilns, especially forced air gas kilns, have a great advantage because I can do highly oxidation firings to highly reducing in a forced air gas kiln. And so of all the kind of kilns there are, you can probably get the greatest range of atmospheres with a forced air gas kiln. Well, this is where I have an air blower and a gas burner, and I can force in a lot of extra air and do oxidation firings, or I can change the air and do reduction firings. So this is the opposite of sort of the opposite end of the oxidation firing in electric is probably this forced air gas, where I have a great possible choice in firings. Electric kilns, you're pretty much limited to oxidation firings if you want your elements to last more than 2 firings, or a short number of firings. As I mentioned before, both the elements and the thermocouples have a limited lifetime. So when you get one, you need to anticipate you are going to have to replace the elements and you are going to have to replace the thermocouple eventually. And replacement elements can be expensive. I mean, depending on how many you have, they can be $50, $60 per element, depending on what you need. And if you need to replace all of them at once, that's going to be a little bit of a shock. The other thing is that for an electric kiln, if it's a 240 kiln, you need to have a separate outlet and a separate breaker, basically a separate line for your kiln. You don't want to have your kiln on a line in your house or your studio with anything else on it. You want it to have your own 240 volt line with its own breaker. So that's a little additional expense for the installation, is having its own line with its own breaker. 2 common types of firings that, in terms of electric kilns are bisque and glaze firing. By the way, you may have heard the term biscuit firing versus bisque firing. This is a kind of an English tradition, but what we call a bisque firing is actually a higher temperature firing than the glaze firing. This is the old meaning of the word. A biscuit, what we actually do, in case you see these terms, what we actually do is a biscuit firing, where the first firing is lower temperature than the second firing. Technically, a bisque firing is where the first firing is higher temperature than the second firing. But you almost don't hear that distinction anymore. We've gotten kind of casual about it. But occasionally, especially if you pick up an English book or a European book, they'll still talk about biscuit firings, and that's what the difference is.
What about kill versus kiln?
I don't know, but kiln? Yeah.
Phil says kill sometimes.
Yeah. Well, I kind of swallow the end. Yeah. Okay, but the main feature of a biscuit firing or bisque firing is a very slow initial heat up and slow through red heat while you're getting rid of the chemical water in the clay, and then you can speed it up. Whereas the glaze firing, you can do the early part of the firing can be very fast because you've already gone through the bisque firing. So when you're doing a glaze firing, the first part of it is you're just repeating the bisque firing. So you can go very fast early on, and then you slow down at the end to mature the glazes. So it's kind of the opposite of the biscuit. The biscuit, you go slow, and then you can heat up, and the glaze, you go fast, and then you slow down. So here's some general firing recommendations. These cover a range of topics, but some general recommendations. Use a bottom shelf. You never fire on the bottom of the kiln. So you always want to have a shelf that's about roughly an inch, like 1 inch posts off the bottom. It used to be, if you didn't have a downdraft fan, it used to be because the bottom of the kiln was cold and you didn't want pots sitting on the cold bottom. If you have a downdraft fan, you still need that because you need the clearance under the fan for the fumes to exit. So either way, you want to have a shelf on the bottom. This is really important. Stacking or loading how you load the kiln really affects the temperature distribution in the kiln. Just because you got a fancy electronic controller and it's got 3 thermocouples and all this stuff doesn't mean that the temperature is uniform everywhere in the kiln. And so, for example, closely spaced shelves heat up more slowly than widely spaced shelves. Because again, it's radiation, how much heat can get in there. And if I've got 1-inch posts with some plates sitting in there, that's going to take forever for the heat to get in there to heat up that space. If you don't have a kiln vent, if you don't have one of those down drift vents, then you want to have wider shelves at the bottom. Because if you don't have a kiln vent, the bottom of the kiln is colder than the top, right? So if the bottom of the kiln tends to be colder than the top, I want to space my shelves more widely at the bottom than I do at the top, so that they'll heat up about the same rate. Everybody follow that? Okay. And remember, the important thing to remember is the heat is coming from the walls. So one of the things to think about when you stack an electric kiln, if you have a choice, is put the tallest pots in the center of the shelf. Don't put a ring of tall pots around the outside and then plates or something low in the middle, because they're going to block the heat. And the only way the things in the center are going to get hot is if the things next to it get hot first, because it's like light. It's the light or the heat shining on it coming from the outside that moves in. When you're loading the shelves, put post over post as much as possible, which means when you put a post and right below it is another post. The reason for that is if I have a shelf and I have a lot of weight, if I have a lot of weight on the shelf, eventually, if the shelf is the kind that will sag, the shelf will warp if I'm pushing a lot of weight down in the middle of the shelf. So the more I can have the posts supporting the weight all the way down, the less stress there is on the shelves, other than the weight of the pots.
Is there a difference between a 3 and a 4 post? I've heard people say that 3 is better than the 4, when you put them in on a shelf. Well,
generally you want to use 3 on each shelf, because that way there's no wobble. The minute you use 4, if the posts aren't perfect, you can get a wobble. But you do need 4 if you've got half shelves, because then but generally you only want to use 3 on a shelf.
So I struggle with that because mine are rectangular.
Uh-huh.
So if I use 3, then the corners, I worry about that. Like if you have like a hexagon shape.
Yeah, yeah.
You don't have that extra, like the corner press them down. So I still use 4, but then I think I'm doing the wrong thing because
You won't hurt them. It's just that sometimes, unless your posts are all, after all, the shelves warp a little bit, and you try to get 4 posts, and there's always that little bit of wobble.
Right.
And so if that doesn't bother, you're not hurting anything.
Okay.
But it's just that, like if I have a tall stack, I don't want the shelves wobbling. And if I use 4, and by the time I get to the top, I can have a pretty wobbly stack. So you're not hurting anything, but you don't need it. That's all.
Okay.
You don't need it.
And Jim Sanford actually uses 3 shelves on a wood fire kiln on square shelves.
And the corners don't
It's
work.
not a problem.
As long as your shelves are decent shelves, then, yeah. And turn your shelves over too.
Yeah,
And it
I
has
figured
flames
that's-
and everything else.
and
Yeah.
it's not rotating. Okay.
Yeah.
All right, I'll be free.
If one of the other trick that I do is before I load any kiln, I'll hit the shelves with my knuckle or my head, and listen to the ring, because if you have a crack in a shelf, you can hear it. Instead of getting this nice tone, you'll hear it. It'll kind of go buzz, and so I don't want to load a cracked shelf if I can help it, and have it fail during the firing. Or let's say I can see the crack, so I always tap the shelves. I always do this, just tap routinely. But also, if you have a crack, let's say especially if it's a full shelf, and I don't want to abandon the shelf, you can use it. Put the crack over a post. So that both sides of the crack are, so that if I have a shelf, so that both sides of the crack are supported. If here's my shelf and here's the crack, I put a post under it so both sides of the crack are supported, and then the crack the chances of the crack won't grow much further. If one side of the crack is supported and the other isn't, then the shelf can do this, and it can kind of tear, or the crack can grow. But if you put the crack right over a post, you may have to move a post to a new location, but put the post under the crack and you can extend the life of the shelf. So as I mentioned already, you want to put taller pots in general, taller pots in the center, so that they're not blocking the shorter pots. You don't want to put pots too close to the elements. I usually generally say an inch, at least an inch away from the elements. And the easy way to do that is don't have them hanging over the shelves. If your pots don't overhang the shelves, then you're keeping a good distance away from the elements. If you're firing large plates and platters, you want them in the center of the shelf, as close as you can to the center, because if you think about it, if I've got a large plate and platter, the first thing that's going to get heated is the rim, and the last thing that's going to get heated is the bottom of the platter. And I don't want it to get heated non-uniformly. I want the whole thing to get heated at about the same rate, ideally. So I want to, if I can, I want to center it. One of the things that I do that I don't know, one thing I do that I can't say I've ever seen proof that it works, but it's kind of a safety thing, is whenever I load, I point the handles away from the elements. I never have appendages or handles pointing toward the elements, because they're going to get hot first. And if they're not firmly attached, and you all know that when you heat things up, they expand. So if I have a mug sitting on the outside of a shelf and the handle is pointing toward the element, that handle is going to get very hot very fast. It's a thin little piece of clay, and it's possible it could aid in loosening the handle or breaking the handle off the pot. So in bisque firings and glaze firings, I always point the handle away from the elements. I may put the mug on the outside of the shelf, but I turn the handle in. And the other thing that's sort of along with that thing is if I have pots that are thicker, especially in a bisque, where I'm concerned about, are they dry and are they going to blow up in the firing, but I'm going to put it in anyway. I put them in the center of the shelf because it's going to heat up more slowly. So I purposely wouldn't put a thick pot on the outside because I know it's going to get a shock. When the elements come on, that pot's going to get blasted. So I put the thicker pieces in the middle of the shelf, knowing that they're going to take longer to heat up and a little slower, and so they're less likely to blow up if they're going to blow up at all. I mentioned already that you can flip over the shelves during bisque firing. If you do put kiln wash, you don't need an expensive kiln wash recipe for electric kiln firing. You don't need, sometimes you've probably heard of aluminum oxide. You don't need that at all for electric kilns. All you need is a 1-to-1 mix of silica and EPK. That works great. You don't need anything fancy for kiln wash for electric kilns. And I'd say if you can, you don't need to buy kiln wash because it's so cheap. Silica and EPK are so cheap. They sell it, and they sell it like 10 times what it's worth. So if you just get a little EPK and a little silica 1-to-1, it makes a great kiln wash. I mentioned already that the kiln sitter is a safety device. Don't use it as a controller. But if you do have a kiln sitter, before you put the cone in the kiln sitter, wiggle the arm with your finger to make sure it's not stuck. Because if they corrode, that arm can stick in position, and you can, if it doesn't move freely, you can raise it up, put the cone in, but it might not drop because there's a little corrosion going on inside the tube. So flip it up and down with your finger a couple of times to make sure it really moves freely. The second sort of suggestion is if you're putting a cone in the kiln sitter, right, one of the small cones, roll it between your fingers like this, roll it back and forth, because occasionally you'll get a defective cone that has a crack in it, and if you put it in the kiln sitter, it'll break and shut off too early. So you can find the defective cones, you put just barely enough pressure on them to roll them between your fingers, and if it's a defective cone, it'll break in your fingers.
How long are cones good for?
Ever. Forever. They're like little clay bodies, so they're fine. But if you use a cone, and let's say the firing shuts off and something goes wrong with the firing, put a new cone in. So don't use half-fired cones or something like that. But yeah, they're good forever. Okay. But yeah, roll the cone between your fingers, and I've had that happen a number of times because they're just mold. They're little ceramic pieces that are molded, and you get one with a crack or a defect in it, and if it snaps, it's going to shut off your kiln. So you can find that by just gently putting a little bit of pressure on it and rolling it back and forth on your fingers. And if it's defective, it'll break in your fingers, and then you know not to use it. And if you press too hard, you'll find that all the cones in the box are defective. Okay? And for what I suggest is that also use the small cones in electric kiln. This is why the small cones were created for electric kilns, because if you use the big kilns, the ones that are like this, you can't see them through the peepholes. You have to put them, if you typically, a cone pack, you use like 3 cones, one lower than the temperature, one the temperature, and one higher than the temperature you're going for. If you use a pack of 3 of the large cones, you have to put them so far back in the kiln, you can't see them during the firing.
And they're more expensive.
And they're more, well, who cares for quality firings, No, I'm kidding. But they are more expensive. But you can't see them. So if you make a little cone pack of the little ones, you can put it right close to the edge of the shelf. And the other trick is, when you go to The other trick is when you go to look at them, is something, you know how sometimes you can't see them because they're glowing so hot? Pull the pea plug out and blow a puff of air on them. Just go, and then look at them. And that cools them off enough that they get dark, and then you can see them. Okay? So don't burn your eyebrows off while you're trying to do it, but pull out the thing and just go, and then look at them quickly, and that'll cool them off just for a second. They turn gray, and then you can see them. Okay?
You're supposed to wear protective eye gear.
Yeah, it's a good idea. It's a good idea. Yeah,
Honestly, I talked to my eye doctor about that because I was getting a cataract, and she said, "You're young for that, right?" And I said, "Is it because I used to do this?" And she said, "No, that's a different thing. But eye doctors know about a condition with potters that was prevalent because of that."
and it's the bright light,
But it's
basically.
not the cataract. It's another condition.
But it's the bright light. I think it's a retina sensitive. It's basically it's a bright light.
They do that.
They used to say that it was ultraviolet light and it's burning your eyes, but it's not. Your kilns don't make ultraviolet light. But it's like looking at the sun.
Right. I mean, it's like a freak thing. I got a cataract when I was like 39.
Okay, well, in the same eye you used to look through the peepholes?
Only my left eye.
Okay.
No, seriously.
Yeah.
Yeah. Mine's only at the right, so yeah.
So you can buy the glass that goes in a welding helmet. Certain
Yeah.
grades of, light.
Right, lightness, right,
You
right.
happen to know which number would be appropriate?
Uh,
5 or a number?
I think I've got one that I think is like 11 or 10. It's pretty dark. Actually, I bought a pair of glasses that I use that for viewing through kilns, and they have a reflective coating on the outside, and then they're also designed to eliminate some of the yellow light. They're called didymium glasses. Didymium. And they...
Some of the pottery places sell them.
Yeah, they sell them, and they're special. And I think they work better because they're not too dark and they're not too light. Some of the welding glasses are just so dark you can't see a thing.
Yeah.
But I would check in the glass. They're worth it, like $30, $35, but they're worth it. So just I'm wrapping up here, but some quick. Let's see if I talked about these already. Common firing problems. Well, I mentioned about using the kiln setter as a controller, so we won't talk about that. Temperature gradients. You can still get top to bottom gradients in a kiln, or you can get a temperature difference between the outside of the shelves and the center of the shelves because of the heating. And this is again why it's important to use cones. Use cones on, and if necessary, put cones at several, don't just put one set in the kiln, put several places. And until you get to know, this is why it's called mapping your kiln if you get a new kiln. Put cones all over the place in the kiln, even if you can't see them through the peepholes, so that when you unload, you can look at it and say, how uniform for the temperatures were the temperatures in my kiln. After a while, you'll get to know what your kiln is like, and then you don't have to put the cones in every time because you'll know how the kiln performs. But that way you'll know, like, is the center a lot cooler than the outside, or is the bottom colder than the top? And you do what's called mapping. So it's worth doing. The other thing I wanted to mention is, because you have this almost unlimited power with an electric kiln, it's possible to heat up a kiln too quickly. And one of the ways this shows up is in glaze firings. And I run into this a lot with teachers where they're under a lot of pressure to crank the work through, and the kids are there screaming and yelling, they want their pots, so they load up the kiln and they put it on fast, and all the glazes run. And the reason why is because, and this is kind of weird, but when we're firing by cones, heat work, but when I fire really quickly, then the final temperature to a certain cone is higher than if I fire more slowly. So if I put a number 6 cone in the kiln, and I'm going to do a cone 6 firing, and I'm going to watch the cone bend, if I fire slowly to cone 6 and the cone bends, or if I fire very quickly to cone 6 and the cone bends, when I fire quickly, the final temperature is a lot hotter than if I fire slower.
Why is that?
Because the cone is measuring time and temperature, so if I've got less time, it takes more temperature to make the cone bend. It's the combination of the two. So if I'm not giving it as much time, I have to give it more heat when it finally bends. So, and it can be 20 or 30 degrees hotter. That's enough for a lot of glazes to make them run. So what typically happens is they do a quick firing, and all the glazes, especially on the outside of the shelves, run because they've overshot the temperature by 20 or 25 degrees by doing the fast firing. So this is the problem. This is a unique problem with electric kilns. It's very easy to fire too quickly. And also even with bisque firings, you know, if you fire too quickly, even with pots that are completely dry, you can blow up the pots because you don't give enough time for the water to come out. So you've got this incredible power at your command, but it's easy to overdo it with an electric kiln. Okay, so just to wrap up, a few things to remember then here. Remember, there's a big difference between electric kilns and fuel-burning kilns with respect to the heating and the way you load the kiln. In gas kilns and wood kilns, I've got this river of flame that's passing through the pots, and so I think I don't have to think so much about a pot blocking another pot, or I can choose it. In electric kilns, I have to worry about that, about what is blocking one pot from the heat from the other. It's, as I mentioned already, it's too easy to fire too fast in an electric kiln. So allow enough time for things to happen. Don't fire by temperature alone, and this is especially true for these electronic controllers. You should still be using cones with an electronic controller, because even though there's no way that electronic controller can anticipate the spacing of your shelves or the thickness of your pots or how many pots you put on the shelf, you still need, which is going to affect the temperature that the pots see. So you still need to use cones. I mentioned already you want to vent the kiln and you want to vent the room. With barrel kilns, insulating fire bricks are not strong. You should never put anything on top of a barrel kiln, on that lid. It's too easy to crack the bricks with any kind of weight, so you never put anything on top of a barrel kiln. I mentioned vacuuming out the element grooves. That's a really simple maintenance thing. When you're chipping glaze off a shelf, if you have to chip it off with a chisel, you always chip toward the center of the shelf. Regardless of where, it sounds weird, but if this is a shelf, and if I've got a glaze drip here, I would never chip it with a chisel that way, because I'm going to break off the edge. I always chip toward the center. If I'm chipping the glaze chips, always chip toward the center of the shelf, because that way you're pushing on the shelf. Ceramics are very weak when you try to pull them. So if I hit this way, there's a good chance I'm going to knock the corner off the shelf. So I always, even if it's down here on the very corner, I'll chip toward the center of the shelf so I don't break the shelf. If you're doing any repairs on the kiln, disconnect the power. This is why you want a breaker, or if you don't have a breaker, pull the plug, because things like relays can stick. So imagine, you say, okay, I'm going to go work on the kiln, and the relay is stuck and the power's still on to the elements. I mentioned already, do a break-in firing with new elements, where you break in the elements by forming the coating. If you're buying a front-loading box kiln, get a kiln that has elements all around. Don't be sucked in by the companies that sell them where they don't have elements on the door. Because there is, in spite of what they tell you, there is a definite effect of not having elements all the way around. There's a portion, we had two kilns like this down at Vizarts in Rockville. And there's a whole, if you look down at the top of the kiln, from the top of the kiln, it was a square. If I look down from the top, and this is the door, there was an area that went like that was considerably cooler than the whole rest of the kiln, because there wasn't a set of elements on the door. So and there are some kilns I've seen in the British, they only have elements on the sides, nothing in the back, nothing in the front. Don't do it. Get ones, if you're going to get a box kiln with a door, get one that has elements all the way around it. And the last thing is, if you're buying a used kiln, remember that there are two kind of power supplies that kilns are built for. 240 volt and 208 volt. If you're buying a kiln for use at home, make sure you're getting a kiln that's good for 240 volt, which is what you have at home. The other side of that is, if you work in a school and somebody donates a kiln, most schools are probably going to be on 208 volts. And so if you get it, and somebody donates a kiln, they're going to probably donate a kiln from the home studio, which is going to be 240 volts. And so and what you'll have to do if you want to make that, you have to replace the elements. So so make sure if you're going to buy a used kiln that the power, it's rated for 240 volts or whatever your system is, wherever you're going to be working. Because we had that problem at Hood. We had somebody donate a 240 volt kiln to the school, and we run on 208, and it never reached temperature. And it was simply the fact that it wasn't wired correctly. So we had to replace all the elements, so the free kiln cost us a lot of money. All right, everybody, thank you for coming. I'm not sure what next month's topic is going to be, but it may be about firing defects. We'll let you know. Check our website. But thank you all for coming today. I hope it was useful.
The Potter's Roundtable is brought to you by Washington Street Studios and our patrons. If you enjoy the show, please subscribe, give us a 5-star review, and tell your friends. If you want to learn more about Washington Street Studios and shared studio memberships, please visit our website at www.hfclay.com. Thank you, and we'll see you again next time on the Potter's Roundtable.